Alrighty, determining limiting reagents or limiting reactants. What is a limiting reactant? In a reaction, if there is not enough of one reactant versus the other, the reaction is going to stop. It's going to stop completely. And then the one that is limiting, the one that is in the least supply, will run out. And that will determine how much product you will make. For example, we've all bought hot dogs and hot dog buns before for a barbecue. Hot dogs are sold in a 10-pack. Hot dog buns are sold in an 8-pack. So when you look at it, you can't make 10 hot dogs. You can only make 8 hot dogs because your buns will run out before you run out of hot dogs. Now, people have always questioned why that is. It really has to do with manufacturing and nothing else. But we would determine our buns as our limiting reactant because that's what's driving the product. It's in the least quantity and it's driving the product out. This doesn't always have to do with mass. It could be something else. So you can't always just look at it based on mass to determine that. So how do you determine a limiting reactant in a chemical reaction? So the steps in determining a limiting reactant are, first of all, you have to balance the equation. And then you have to convert both of the masses for your reactants into the mass of the products. So you're going to have two problems, both reactants set up and calculate all the way across mass to mass. The reactant that produces the lesser amount is the limiting reactant, and the reactant that produces the greater amount is what we call an excess. An excess reagent or reactant is the one that's going to produce the greater amount, but it's also left over. So in our hot dog and hot dog bun example, the hot dogs are in excess. By the time we make all of our hot dogs together, we're going to have 8 actual hot dogs where the meat is inside of the bun. That means our buns are limiting. They're going to run out first. And our hot dogs are in excess. We can only make as many hot dogs with meat in them as we have the smallest amount, which is buns. So we're going to have hot dogs left over. The excess reactant is also left over in the container. Alright, so let's try an example. We're going to have to set up 2 problems here with 500 grams of nitrogen and 100 grams of hydrogen. Okay, so mass to mass for both of these guys after you balance. Okay, so I know that was quick. It can take a long time to write. So basically what I've done is I'm doing mass to mass. I'm taking the mass of the nitrogen and the mass of the hydrogen, and I'm converting them both to the mass of the product. And I'm going to do both of these, and I'm going to see which one gives me more. So multiply over across the top, all the way across the bottom, and then divide. Okay, so I've done my math here, and this is just like in stoichiometry. It's just mass to mass. Now I'm going to compare the two. So it looks like this one is going to make 608 grams of ammonia, and this one's going to make 1,124 grams of ammonia. So the 500 gram nitrogen is actually going to produce less ammonia. So my nitrogen right here is my limiting reactant. See, even though I had a much larger amount in here, it's still going to limit the reaction. And this guy right here, hydrogen, is what we call in excess.